All right, guys, welcome back. This is going to be simplifying expressions using your trig identities. This is part 2 of Tuesday, March 24th. Okay, once again, you're going to need these identities. And the more familiar you are with them, the quicker this will go. Okay, so in your notebooks, remember, anything that we write down, you want to write down because we're going to check those notebooks when you get back. All right, so main goal. Just like if you're going to add, subtract fractions, you need common denominators to be able to do that. So our common denominators here, when simplifying using trig identities, is trying to get things written in terms of sine and cosine. If you can get things into sines and cosines, you can usually find something that's going to cancel out. And things can cancel when you have exactly the same thing on the top and bottom. What you're doing here is that if you take a look at the problem that you have, this problem is a multiplication problem. And so eventually something in this problem is going to cancel out. Now, if and when we have to use a Pythagorean identity, you are wanting, or a trick to see when you're going to use Pythagorean identities would be when you have a trigonometry squared, like a sine, cosine, secant, cosecant, tangent, cotangent, squared, and it's being added or subtracted with a 1. Because if you look back at all of your Pythagorean identities, as I mentioned in the previous video, everything is squared and every problem has the plus. So that's a nice clue as to when you would use the Pythagorean identity. So this problem doesn't have any squares or any adding and subtracting of 1. So that means that we get to use, most likely, most commonly used, are the reciprocal identities. Okay? So in other words, how can we turn cosecant, how do we turn cosecant right here? How do we turn cosecant into a sine or a cosine? Well, if you look at your reciprocal identities, right here is cosecant theta equals 1 over sine. So I can take this cosecant and write it as 1 over sine x. Then, too many markers, the sine x, which is already here, gets rewritten down here as sine x. And really, guys, if you remember, everything is over 1. And if you remember back to Algebra 2, you did simplifying of rational expressions. You could cancel things that are exactly the same on top and bottom. So the sine x on top, you can't see that. The sine x on top will cancel with the sine x that's on the bottom. So I'm going to rewrite this. 1 over sine x times sine x. And so since you have a sine x on the top and a sine x on the bottom, those will cancel. And so we ask you, hey guys, what's remaining? The only thing that's still here is a 1. And that's the simplification of that problem. So, again, gonna really help if you recognize and can recite these trigonometric identities relatively quickly. The better you know your identities, the more efficient you'll get through these problems. All right, let's move on to our second problem. All right, tangent x, cosine x. Turn everything into sines and cosines. Tangent. On here, on your quotient identities, you'll see tangent. Tangent can be turned into a sine over a cosine, which is our goal. Turn things into sines and cosines. So tangent is going to turn into sine x over cosine x. And that is being multiplied by a cosine x. So I'll just put a little arrow with my pencil that the tangent x turned into using a, reciprocal identity. It turned into sine x over cosine x. And now you can probably see that the cosine x and the cosine x, one on top, one on bottom, are going to cancel. Okay, and what's left? We're left with sine x. And that's the answer. Now, they're not always this easy, and so hopefully our next one's a little bit more challenging, just so you can be pushed a little bit. Well, what's that you say? You see a square and a subtraction sign? Well, good job. That is a Pythagorean identity. But which one? And it's not exactly the same. So you see that it has a 1 and a sine. 1 and a sine squared. Well, this top one has a 1 and a sine squared, but it's not in the same order. And so you are allowed to algebraically rearrange these so that if we were to subtract, hang on just a second, what you need a negative sign. So you're allowed to take this sine squared and subtract it to the other side so that cosine squared theta equals, that is incorrect, 1 minus, that's so incorrect again, sine squared theta. And this right here is what you have on the other side, on the other page, in problem number 3. Okay, so now, right here, this is Pythagorean, and we just showed that it can be manipulated to 1 minus sine squared theta is actually equal to cosine squared theta. So we can take the 1 minus sine squared and say, you know what, we're going to call this cosine squared. And we'll put that in parentheses just because the problem has it in parentheses. Okay, secant x. Where's your identities? Where is secant? Secant by itself is right here. Secant squared is the same thing as 1 over cosine. So this is just a reciprocal. So we can call that 1 over cosine x. And I just realized in the previous problem, I called this a reciprocal identity. That's incorrect. It's actually, could call somebody out there. That's a quotient identity. Okay, so now what happens here? Well, remember that cosine squared really means you have cosine times cosine, and then you have 1 over cosine. So it's a 1 for 1 cancellation. You have 1 on the top, and you have 1 on the bottom. And that's your cancellation. So what remains? we'd have a cosine. Yeah, and I did a bad thing. Should have put x on all three of those. Don't get lazy. All right, it's problem number 3. Got one more for you in video number 2. Last problem. Of course, it's a doozy. It's all good. You guys can handle this. All right, you got 3 different things in this problem. So I highly recommend that you separate them. 3 different pieces. So you've got tangent x, you got cosecant x, and you got 1 plus tangent squared x. So 3 different pieces. So I suggest you write them horizontally as multiplication. Tangent x times cosecant x times, and notice that the 1 plus tangent squared, that's on the bottom. So when you write it as multiplication, you have to write it on the bottom of a fraction. 1 plus tangent squared x. Okay, sines and cosines. Tangent. Tangent is sine x over cosine x. Cosecant is 1 over sine x. And you can start to see, hopefully, where things are going to start to cancel. Okay, 1 over tangent squared x. Let's see what Pythagorean that is. Tangent squared plus 1 equals secant squared. All right, so really, you have one more reciprocation to do right here. So let me just write this out for you. This was a quotient. This was a reciprocal. This was Pythagorean. And we have one more reciprocal to do because this is not a sine or a cosine yet. So I'm going to jot all that back down. Sine x, cosine x, times 1 over sine x. And here is where we reciprocate. Secant is the reciprocal of cosine. So we're going to get times cosine squared x. And that is on the top for those of you that want to pay attention. All right. Cancellation time. Got a, now we cancel, sine on the top, sine on the bottom. We have 2 cosines on the top and 1 cosine on the bottom. So this is getting technical. Gotta be careful. One of these cosines cancels with one of these cosines. So that's all the cancellation we have. And so what's left in all of this problem right here is cosine x. Okay, and that's it. That is simplifying. Really, really is going to help for you guys to know your identities. So once again, this becomes pretty important. Print this off the blog. I have this printable exactly like this, except for my handwriting. Paste that into your notebook. Start a new page. And it's going to greatly, greatly, greatly speed things up for you. I did not print out your homework page, but before you guys left for the break, I gave you a blue packet. The cover page was blue. Those of you that weren't here on the final day, this is on the blog. You can download the whole thing or just use piece by piece. however you need. Page 1 is solving with the identities, and then page 2 is the simplifying, like this video number 2. And I'd like you to try numbers 1 through 20. So it's approximately 10 simplifying and 10 solving. Office hours are, as usual, for pre-calculus is going to be from noon to 2 p.m. So I look forward to talking with you guys tomorrow. You guys have a wonderful Tuesday. And good job on your test today, guys.